So this video is going to cover addition and subtraction of numbers that are written in scientific notation. Addition and subtraction is a little bit tougher than multiplication and division. Requires a few more steps. It's a little bit tougher to kind of mentally think about, but just pay attention. Again, kind of showing that work and showing those steps is going to help you through this. So let's start out with something like 8 times 10 to the 5th plus 4 times 10 to the 5th. Okay. So in this particular scenario, we've got the exponent to be the same, all right? And this is just an example of where we can use the distributive property. If you notice, we're taking the 10 to the 5th and we're distributing it to each of those two numbers, right? Well, if I know it's a distributive property, I can rewrite it then as this, right? I can add those front numbers together before I multiply it times 10 to the 5th power. Okay, it's just an example of the distributive property. So when I think about it like that, I can see that, well, that's then 12 times 10 to the 5th power, right? We can add those front numbers together. Now, that number is not in scientific notation, so we'd have to go, well, 12 is 1.2 times 10 to the 1st times 10 to the 5th, right? And then we'd end up with 1.2 times 10 to the 6th, okay? But it's a fairly straightforward, simple calculation when those powers of 10 are the same. We just want to add those front numbers, or if it's subtraction, subtract those front numbers, and then at the end convert it to scientific notation if we need to, right? Again, just a reminder that front number has to be at least 1. It has to be less than 10, so 12 is too big. So we had to rewrite 12 as 1.2 times 10, and then combine that with times 10 to the 5th to get times 10 to the 6th. Okay, now let's look at what happens when the powers of 10 aren't the same. So let's say we had 6 times 10 to the 5th plus 2 times 10 to the 8th. Okay, so in this case, we can't just go 6 plus 2 and add those together because our powers of 10 aren't the same. Okay, if we want to think about the kind of the traditional algorithm of addition, like 6 times 10 to the 5th in standard form would be 600,000, and 2 times 10 to the 8th would be oops, I think I screwed up lining up my zeros. Let me add another 0 in there. I apologize. There we go. Would be 200 million, right? And if I were to add those together, I wouldn't add the 2 and the 6 together because they're not, they don't have the same place value. Okay. Now again, we don't want to have to convert it back to standard form to add those because that defeats kind of the whole purpose of scientific notation. Okay. So let's talk through how we would deal with this, right? And again, I'm going to use addition, but if it's subtraction, the same rules apply. We would just subtract rather than add. Okay. So what we want to do is we want to be able to get that power of 10 to be the same. All right. So I'm going to show you 2 ways. Let's start with I want to convert 10 to the 5th and make it 10 to the 8th. Okay. Well, let's think, what do I do with 10 to the 5th to get 10 to the 8th? Well, I've got to add 10 to the 3rd power to that, right? Or I've got to multiply 10 to the 3rd power, and then we add 5 and 3 to make 8. So I'm going to convert this into 6 times 10 to the 8th, right? And if I got to add 5 plus 3 to get 8, that means if I have 10 to the 8th, right, I've got to subtract 3 from that. Okay, so I haven't changed my value here. 6 times 10 to the 5th is like 6 times 10 to the 8th times 10 to the negative 3rd, right? 8 minus 3 gets us 5. Okay, and then I'm going to rearrange this like that. Okay, now what I can do is I can simplify that part, right? So times 10 to the 3rd, we're going to move our decimal left 3 places to get that, times 10 to the 8th. And then I have plus 2 times 10 to the 8th. Okay. Now that my powers of 10 are the same, I can use my distributive property. So now I have 0.006 plus 2. Right, and I can combine those together, times 10 to the 8th. Okay, let's go over here. That's 2.006 times 10 to the 8th power. And that is in scientific notation. Our first number is at least 1 less than 10. Okay, so in that case, we took our smaller exponent and we changed it to make it our larger exponent, right? So I basically took and said I need 10 to the 8th, right? What do I do with 10 to the 8th to get 10 to the 5th? Well, I have to subtract 3 exponents, so times 10 to the negative 3rd, right? Did some rearranging of the numbers. Okay, took this front part again and rewrote that. In this case, is 0.006. And then once I have 10 to the 8th and 10 to the 8th, I can add my fronts together to get my number in scientific notation. Okay, now sometimes it's hard, and I even struggle a little bit sometimes with thinking about, what do I do with 5 to get 8? Well, I've got to add 3, right? So then we kind of have to think backwards. Well, if I want to start at 8, I've got to subtract 3. So sometimes that's a little bit hard to process. So sometimes it's easier. Let me rewrite this here. Sometimes it's easier to do the other way. So again, I have 6 times 10 to the 5th plus, 2 times 10 to the 8th. So what we can also do is we can take the other exponent and we can try, in this case, 10 to the 8th, and try and turn it into 10 to the 5th. Okay? So if I think about, I want to end up with times 10 to the 5th, right? Well, what do I do with 5 to get 8? I also have to have a 10 to the 3rd. Okay, 10 to the 3rd and 10 to the 5th together make 10 to the 8th. We add those exponents. Okay? So now I have that, right? I haven't changed the value over here. This 10 to the 3rd times 10 to the 5th is still equal to 10 to the 8th, right? Because 3 plus 5 is 8. So now I want to take that and I want to deal with this front part. Let's simplify that part. And so that gives me 2 times 10 to the 3rd, which is 2,000, times 10 to the 5th. Over here I've got 6 times 10 to the 5th, right? So we've got that same exponent. So now I can use my distributive property. So 6 plus 2,000 times 10 to the 5th, right? And that's going to be 2,006 times 10 to the 5th. Now the disadvantage here is it's not in scientific notation, okay? I think it's a little bit easier to work with the exponents in the beginning because you don't have to deal with negatives and subtraction, and to me it's a little bit easier to think about. The downside is now you've got to change that into scientific notation, okay? So let's do that. So 2006, I'm going to come over here, it is 2.006 times 10 to the 3rd, and then we have times 10 to the 5th. So 2.006 times 10 to the 8th power, right? So we can see we get the same thing. It's a little bit easier to me on the front end. The back end, though, you have to be able to then rewrite it in scientific notation. Again, we can see that we get the same answer. So it's really a personal preference. You'll find as you practice these, you'll kind of do one over the other, which is fine. I just showed you both methods just to show it doesn't really matter which one you change. They both kind of have their positives and their negatives, but again, the key concept here, we've got to take that power of 10 before we add or subtract, and we have to get it down to the same. So you're either taking that smaller one and increasing it, or taking that bigger one and decreasing it to get those powers of 10. Once the powers of 10 are the same, we can apply that distributive property to add our front numbers. And then we just want to make sure that we rewrite our answer. If it isn't in scientific notation, make sure you rewrite it in scientific notation.